Well, hi friends, welcome to Chapter 5, Lesson 5. Go ahead and do these warm-up problems here and check your answers when you're done. Okay, here are your answers. If you got more than one incorrect on this one, I'd like to meet with you before you move on to the next lesson. Okay, we're going to continue to talk about algebra, and we're going to look at different algebraic expressions and try to determine what the different parts of that expression are, so that we can then combine different like expressions and make the simplest algebraic expression possible. Okay, so this one we're going to identify the terms, like terms, coefficients, and constants in the expression 6n minus 7n minus 4 plus n. Okay, so first of all, we want to rewrite our expression. Now, rewriting can include different things, but the biggest thing is whenever you have subtraction, remember, subtraction is the same thing as adding a negative. And it's much easier to simplify when you've got addition rather than subtraction. So we're going to change 6n minus 7n to 6n plus negative 7n. So that minus the subtraction sign just carries over, attaches to that 7n, and then we put an addition sign in between. Do the same thing over here to the negative 4, or minus 4, subtraction 4, and make that addition of negative 4. So now that we have that expression rewritten, then we can take a look at the different terms. Now, a term is any part, number, or letter that is in between any sort of process. So like, for instance, addition would be a process, multiplication would be a process, and this is a term, and that's a term, and that's a term, and that's a term. So we want to go ahead and isolate each of the terms in that expression, okay? It's basically just the parts, the building blocks of that algebraic expression. One thing I forgot to mention is whenever you have a variable by itself, right here, there's no number or what we'll call a coefficient. I'll explain that in a second. It's always 1. So if there's one variable there, it's always the same as 1n. So n is the same as 1n. Okay, so we have our terms listed down here. Now we want to combine like terms. Now what we mean by like terms are any terms that have the same variable. Now, a variable is a letter, and what that means is that that letter, what we plug in there, can vary depending on the situation. So n might be 2, n might equal 7, n might equal negative 2.5. That can vary, but then this part, let me erase that so you can see. So that's the variable, and this is a coefficient, what we call a coefficient. So within a certain term, let's say we have 2y. So this whole thing is called a term. And then this would be the coefficient, and this would be the variable. This whole thing is a term. So when we look for like terms, we're looking for terms that have a similar variable. Okay, so in this case, the similar variable is n. So we separate out those 6n, negative 7n, and we'll go ahead and put 1n in there. And then we separate out the coefficients. What are the different coefficients that are attached to those variables? 6, negative 7, and 1. Okay. And then a constant is any term that does not have a variable with it. So if it's not variating, that means that it's constant. So if it doesn't have a variable, then that makes it a constant. So the only constant that we have in this particular expression is negative 4. That's the only term there without a variable. Okay, so we've identified the terms, we've identified like terms, we found the coefficients, and we found the constants. Go ahead and work this problem through, identify each of those same areas, and then check your answer when you're done. Okay, so there you have it. Your terms, once you change that, right, 3x plus negative 5, remember subtraction is the same thing as addition of a negative, plus 2x plus negative x. So we separate the terms out. We have 3x, we have -5, we have 2x, and we have -x. That's what we have here. Like terms, we separate the terms out with the same variables, 3x, 2x, and -x. Coefficients with those variables, we have 3, 2, and -1. Remember, -x is the same thing as -1x. And then the constants, the only one in this one is -5, is that constant. Okay, so now we're going to write 4y plus y in its simplest form. Okay, so 4y and y, we know are like terms because they have the same variable. Remember, 4y is the, y is the same thing as 1y. So then we can change this expression here into that, 4y plus 1y. And then we can use the distributive property to keep y as it's in itself, and then we know that we're going to add 4 plus 1, right? Add our coefficients there, and then multiply that by the variable. So notice what we did. We've got a similar variable in each of these terms. Okay, so if that's the same, we just drug that same variable down here and put it on the outside. Then we saw, okay, I have 4 plus 1 that's left over. So 4 plus 1, and then I can multiply that by y. 4 plus 1 multiplied by y. So I basically took this 4y plus 1y, and I added the coefficients together, kept that same variable, and the simplest way to write that expression is 5y. Okay, go ahead and work your way through this one. Right, should have got an answer of 5n. 6n plus -1n. Remember, subtraction is the same as addition of a negative. Also, when a variable is written by itself, that's the same as one of the variable. So if I take 6n and I add -1 to it, that would be 5n. That's the simplest form. Okay, now we're going to have a little bit larger of an expression here, and we're going to write that in simplest form. Okay, so first of all, what's the like terms? 7x and -7x are like terms in this case. They have the same variable. And again, we change this to be 7x plus -2 plus -7x plus 6. Okay, so these are like terms. They have the same variable. And then these are like terms. They have the same variable, which is none. So we rewrite that out. Then you use the commutative property. You move those each into those terms around so that you get them close to their like terms. And then we see very soon that 7 and -7 will go together quite well because they just cancel each other out. And we see that 0x plus 4 is what we're left with, but 0x means no x, no 0, or no variable there. So the simplest way to write this would be just simply 4. 4 is the simplest form of that expression. Okay, go ahead and try this one on your own, and then check your answer when you're done. Should have got an answer of -3. So rewrite the expression 8z plus z plus, I'll put that there so we know that's a z, plus -5 plus -9z plus 2. So first of all, we want to isolate the like terms. So we've got z's here, and we have just normal constants. Okay, so 8z, I'm going to use the commutative property to put these different ones together here so that we know what we're dealing with. Okay, and then plus -5 and plus 2. So I have 8z plus, that's 1z, right? And if I add those two together, that gives me 9z plus -9z, which we know those two will cancel each other out. we end up here with 0z plus -3. That is nothing, so our answer is -3. Okay, real world problem here. The cost of a jacket, J, is what that will stand for, after a 5% markup can be represented by the expression J, which is the cost of the jacket, plus 5% of J, or 0.05 times J. So we're going to simplify that expression, and then we'll determine the cost of the jacket after the markup if the original price is $35. Okay, so here's our expression. J plus 0.05 times J, which is the same as 1J plus 0.05J. Then we use the distributive property to say these are like variables. So we take the coefficients on the in front of those variables and we stick those inside of a parentheses. We're going to add those together ahead of time and then multiply the sum by J. So we get an answer of 1.05 times J. Now we go ahead and plug $35 in as the cost of J, and you get the answer of $36.75, which is the cost of the jacket after a 5% markup. Okay, work this one through on your own here and check your answer when you're done. Okay, you should have gotten the answer of 1.25C as the simplified expression, and $50 is the cost if the original price is $40. Okay, again, 1C plus 0.25C. C is the same as 1C. 0.25C, we add that together, that's 1.25C. And then if we plug that in for or if we plug $40, 1.25 times 40, the original price of the DVD, then we get an answer of 50. All right, at a concert, you buy some t-shirts for $12 each and the same number of CDs for $7.50 each. So as many t-shirts as you're buying that number of CDs. Maybe you're buying for Christmas presents where you're getting a t-shirt and a CD, and that's going to be what you give. So we're going to write an expression then in simplest form that represents the total amount spent. Okay, so X is going to be our variable that we use to represent the number of t-shirts and CDs that we're buying. So we look at this, we know that we're going to buy whatever number of of t-shirts will be represented by 12X, right? X is however many we end up getting, and each one of those is going to cost us $12. So 12X, and then we're going to add to that the same number, X. Notice that carries over the same number and of CDs, and each of those CDs costs $7.50. So we get 750X to represent that. Then we use the distributive property to separate out the coefficients in the variable. We can add those two coefficients together, 12 plus 750. We get an answer of 1950X. So the expression 1950X represents the total amount spent, and X can be whatever number of these package deals that you're going to buy. Okay, you work through this one here and check your answer when you're done. Okay, you should get an answer of 775X. So we're going to use X to be our variable. So we have 485X plus 290X. And we're going to just simply separate that out, 4.85 plus 2.90, and times that by X. When we do the math there, we get an answer of 775X. Okay, so we have learned how to identify the terms of an algebraic expression, separate them out into like terms, and then also use the distributive property to get the coefficients into its simplest form in front of those variables.